Hi, I'm Pat Kelly. Okay, and in this problem, we're asked to decide if the variables in this differential equation can be separated. So we're learning about that separation of variables technique in differential equations. So we have to decide if we're going to be able to use that technique. So that decision is going to be based on whether I can manipulate this equation so that all of the x's are on one side and all of the y's are on the other side of the equal sign, trying to separate the variables. So I have to be thinking very algebraically. I'm just trying to decide if I can do the right algebra so that this equation does have all the x's on one side and all of the y's on the other. So when I go to do my algebra here, let me also try to explain that these differential statements, these derivatives, dy dx, you now want to try to feel comfortable separating them. I mean, see that as a fraction with a numerator and a denominator. The only thing you're not allowed to do is separate the d from the y or the d from the x. You have to think of them as single entities. This is what we call a differential element. So when I go to do my algebra, I'm allowed to play with that fraction as long as I keep the dy together and the dx together. So now here's my algebra. I'm actually just going to cross multiply. It's the way a lot of us think of two fractions equaling each other. So if I cross multiply here, I'll have y plus 3 times dy equals x times dx. Okay, I did a lot of talking and not much writing because that's what I was seeing in my head is just a quick cross multiply. Something we've seen before. Okay, that's the algebra, but now the question is, did I separate the variables? Did I get all of the x's on one side and all of the y's on the other side? And when I've been saying that, I didn't say at the time though, but that includes those differential elements. So all of the x's, including dx on one side, all of the y's, including dy on the one side. And I've accomplished that. They asked us if the variables were able to be separated in this differential equation. I was able to get x on one side, y on the other. So yes, these are separable. That answers that question, but let me throw something else at you, because you'll do a few of these and you might start thinking, well, if I do the right algebra, I'll always be able to get the x's on one side and the y's on the other. So I'll throw a different problem at you. And I just want to consider it for a minute. Think about the algebra that you can do. And remember the goal of trying to get x's on one side and y's on the other. You're going to be able to do or try to do any algebra and not be able to get the x's on one side and the y's on the other. I mean, a real quick thing might be to throw that differential element of dx on the other side, but you'd still have the x plus y in parentheses on the left-hand side. And the significance of that is that you're leaving an x over here, and you're not going to be able to get it over there without taking a y along with it, because I would have to distribute through the parentheses and get that dy element. So this is an example where you would not be able to separate, not separable. I just don't want you to think that you're always able to do it or that it's a limitation of your algebra skills. Sometimes there's no matter what algebra you do, you're not going to be able to separate the variables. Okay, there's our answer, and hopefully that helps. Thanks.